Okay, here we have another sequence. We're going to try and find the nth term for this sequence. Right, start by looking at the differences between each of the terms. I can see the difference between 6 and 11 is 5. The difference between 11 and 18 is 7. And the difference between 18 and 27 is 9. And between 27 and 38 is 11. So I know that it's not a linear sequence because there isn't a constant difference here, so we've got to go again. Difference between 5 and 7 is 2. Difference between 7 and 2 and 9 rather is 2. The difference between 9 and 11 is also 2. So I now know that it's a quadratic sequence because there are two differences, two stages. Right, I have the number 2 here, and to find the first part of my rule I know I must halve it. Half of 2 is 1, so the first part of my rule is 1n squared. I don't need the 1, so I'll get rid of that. Okay, I'm now going to substitute each of these term numbers here into my rule n squared to create another sequence so that we can compare it. So, n squared, well, if n is 1, 1 squared is 1. If n is 2, 2 squared is 4. If n is 3, 3 squared is 9. If n is 4, 4 squared is 16. And if n is 5, 5 squared is 25. Right, now we're going to have a look at the difference between n squared and this sequence here. So the difference between, I know that I'd have to add 5 onto 1 to have 6. Let's add 5. I'd have to add 7 onto 4 to have 11. I'd have to add 9 to 9 to equal 18. Add 11 to the next one, and add 13 to 25 to equal 38. And if I look at these particular numbers, I can see that this is another sequence all in its own right. So what I want to do here is start by trying to find a constant difference. So if I look for a difference between 5 and 7 is 2, difference between 7 and 9 is 2, difference between 9 and 11 is 2, and the difference between 11 and 13 is 2. And because this is the first difference, and it's a constant difference at the first stage, I know that this is actually a linear sequence. So this part of the rule, the first part, will be 2n. Okay, I'm now going to substitute n into this part of the rule to create another sequence. So where n is 1, 2 times 1 is 2. Where n is 2, 2 times 2 is 4. Where n is 3, 2 times 3 is 6. Where n is 4, 2 times 4 is 8. And where n is 5, 2 times 5 is 10. And here we go again. Let's see if we can find the difference. Right, well, I know I can see here that I have to add 3 to 2 to equal 5, so that's plus 3. I have to add 3 to 4 to equal 7. I have to add 3 to 6 to equal 9, and I have to add 3 to 8 to equal 11, add 3 again to 10 to equal 13. So the second part of the linear sequence is 2n plus 3. And if I now combine that with this part of the rule, well, I know it's a quadratic sequence. It starts with n squared and it continues with 2n plus 3.